Hello and welcome back to the lab. I'd like to once again thank all the patrons who help make this channel possible and all the subscribers that we've added to the channel lately. Welcome, and we are very glad you're here. Let us know how we're doing. I read all the comments, and the feedback always helps make the channel better, so let us know in the comments if there's anything you'd like to see, and we'll see what we can make happen. In this video, we're going to take a look at a calibration generator for scopes. This is the PG506 that I've been using to do a lot of the scope cals that are on the channel so far. This one started giving me a little bit of problems during the 465B calibration, specifically with this control right here. This pot was noisy and sticky and wasn't working that great, so we're going to open it up, take a look at inside, and then see about getting the controls serviced, and then we'll do a calibration on this so we'll know it's in spec. Before I started using this to do the calibrations, I calibrated this prior to starting on YouTube with my 6500. So the accuracy on this is being used by the DMM6500. I'm going to recalibrate this with the DMM6510, so we'll be able to dial it in even better. I do have plans, because the 7510 is the basis of the accuracy in the lab, at least for voltage, current, and resistance, that I am planning on sending that out when it comes due. It's going to have to head back over to Keithley for about a week, and it's going to soak up some of the PPMs that are over at Keithley and then bring those back into the lab. When it gets closer to the time, I'll if it's of interest to everybody, I'll do a quick video on it. But have plans to send it off. I do plan on paying for the additional data that comes in with calibration, so that will give me offsets and a few other things. In terms of calibration, using the 6500 or the 7510 as the basis of truth, for lack of a better word, in the lab, both of those were purchased new. So I got those factory new from Keithley with a Keithley calibration on them. So the 6500 is out, because I had that one before I got the 6510, or the 7510, sorry. The 7510 is still in calibration till January, I believe, is when he's got to go out. May send him out before then, because I talked to Keithley and they said they get busy around January, so I guess that's when everybody, during the Thanksgiving to Christmas holidays, that's when everybody kind of sends their gear off to get calibrated during that lull in time. So, but that's just some of the plans for the lab, and also why we'll be using the 7510 for this. A 6500, a 6.5 digit meter, is plenty good for calibration of this, as long as you trust it. I'll look up what the DC spec needs to be, because this is the Amplitude generator for when you do the verticals on a scope. So I'll look up what the DC spec is, but I do know the DMM 6500 met it and exceeded it, which means the 7510 will be plenty. So with that, we'll get into the video. Okay, I've taken the side panels loose. They just pop off like all the TM500 frames. But this thing is absolutely stuffed with circuitry. There is not a lot of room in here at all. Here's what the other side looks like. Still not a lot of room in here. I'm going to look at some of these capacitors. Like, I'm going to see about these guys, if they need to be changed, since I'm going to be in here, and I'm going to do a full recal on it anyway. Just see if some of the electrolytics need to be changed. Just in my observation, this looks suspect. This doesn't look healthy. I'll see what's going on there. That's going to be a tantalum. Here's the precision resistor network for the attenuators. Kind of a big tantalum there. Everything looks okay on this side. Probably take this board out. That should let me access the cam switches and get in to service them, because it's Tektronix equipment, so we know what that means. Cam switches are gonna need to be addressed at least a little bit. This does generate some pretty high voltages on here. Yeah, there's the switching transformer, I believe, for the power supply. So there are, when you're in this particular plug-in, even though the frame is I think it's a plus minus 20, I think it's 28 volt supply, don't quote me on that, but this frame generates 100 plus volts. So there are some elevated voltages in here, nothing like working on a scope or tube equipment or anything like that, but there's, yeah, it gets interesting. So probably I will take some photographs of this. As usual, I'll put the pre-work, the technician's photos on Patreon, just so if anybody else works on these, they, I just snap a whole bunch of quick digital pictures with my camera for gear as I get it. When I start working on it, that way, like these connectors, I know which way they go. Is the black one or the white one in the front? That type of thing. So it just helps me get everything hooked back up when I put everything all back together. So we'll get in here, we'll service this. This electrolytic we'll test. Probably won't need to change him. Because this is a DC calibrator, the supply on here needs to be incredibly quiet. So definitely want to make sure the filtering is okay. I see another possible couple of electrolytics in here that I may want to replace. See about them hiding, just so the board will stand the test of time and be good for another 20 or 30 years. The only difference that I'm aware of between the PG506 and the PG506A is in the high voltage section, or the high amplitude out. The PG506 goes up to about 60 volts. The 506A does the full 108 volts that the Type 180 or the Type 106 does. So I've gotten some questions when I'm doing a scope cal of why I switch from the PG506 to the Type 106. It's because this is only limited to 60 volts on the high amplitude. I can get up to 100 volts on the 106. And the 106, because this is limited to 60 volts, it doesn't necessarily trip the tunnel diode pulsers. So it's strictly a current thing. The 106 can fire the tunnel diode pulsers, so that's why I sometimes need to switch units. Oh, the VAR knob may be upside down. I'll have to look at that. Yeah, I think VAR's on upside down. But yeah, you still have the fast rise and fast fall. No, fast rise, fast fall. Fast fall is plus 1 volt to 0. Fast rise is minus 1 volt to 0. So fast rise, fast fall. If you get them backwards, it can mess up a calibration. Other than that, this restoration should be pretty straightforward. So I'll get into taking this board apart, and then I will bring you guys back. Okay, I'm about 3/4 of the way through the rebuild process. I've been getting the caps swapped out. I will test some of them. It did end up needing to be done. There were some capacitors on this unit that were very bad. So the caps that I've changed so far is this bulk electrolytic that's down here. So this one's replaced, he's replaced. Just got that capacitor in. This capacitor got replaced. There are 2 capacitors in here. There's one's hiding on the other side of the switching transformer that got replaced, and I need to replace these 2 yet. On this particular unit, the large bulk capacitors were okay. The switching cap and the DC cap, they were fine. However, the smaller 2.2 electrolytics were real bad. So a lot of them were testing open. Some of them were testing even like 40 ohms ESR. So very, very toasted. So just wanted to get some video of this while it was open. I'll be posting the tech photos to the Patreon page, which are the pre-work photos, essentially. If you're going to open one of those up, I take detailed photos of the connectors and everything like that so I can get everything back in, because polarity is very important. So I'm going to get those other two capacitors replaced, and then we will plug it in and hope it works. Okay, I've got everything set up for giving this a test. All the capacitors have been replaced. Haven't even fired it up yet. So in theory, got it set to 1 volt per division, 5 volts on the calibrator, standard amplitude. In theory, I turn the power switch, we get a square wave and no smoke. Do need it plugged in. Okay. Take 2 with power. Ah, it's 0.5, not 5. Cool. So, 5 volts per division. Look at that. Awesome. Okay. So, I'm going to put the covers back on. I'm going to let this burn in for a while. Just make sure it doesn't do anything stupid. And then we'll get into an alignment procedure, because I think this one's ready to go back up there. Okay. In getting ready to do the calibration on the PG506, I've been going through the equipment requirements, and I've been asked to go into a little bit more detail on some of the equipment requirements and how I'm doing things in the lab, because sometimes, and this is going to be an exception, usually I follow the manufacturer's procedure. This time I am not. I'm going to be going through the manufacturer's procedure, but I don't have the equipment they call for. I'm not going to use the equipment they called for. Some of the equipment they call for, especially because I have an early serial number of the PG506, is woefully out of date, just by the connectors they use. They want an S1 head, which is a GR784 connector. Everything now is on BNC. Even this is on, even the PG506 is on BNC, but I digress. So the equipment we're going to be using for this calibration is, I'm going to be using this resistor, which is a 1 mega ohm 1% resistor. It wants the calibration wants a 0.1% resistor. This particular example measures at 0.92%. So this is within spec for the calibration. The meter's taking a while to do the measurement because I have it at its highest accuracy of 15 power line cycles plus filtering plus 4-wire measurement for the resistance, so I can get the most accurate resistance measurement possible. Other equipment we're going to be using for this calibration, the 6510, or the 7510 we're going to be using for the calibration. The 6500 we're going to be using for some voltage rail alignment. Frequency standard in the lab is the Agilent 53131A, backed up by the GPSDO, that has been running for weeks and weeks and weeks and weeks as a 10 megahertz reference. In lieu of the 7S sampling heads for the calibration procedure, I'm going to be using the DSA602A, and that's for the fast rise time measurements, adjusting the capacitors for the fast rise time. I'm going to be using the 11A72 on that one, which is the 1 gigahertz plug-in, so that'll give us a gigahertz with a rise time of about 350 picoseconds. I need 1 nanosecond, so we're well within spec there. I would use the 11801C below, but still lacking sampling units for him. DSA 602 is where we're at. So I have our resistor. We have a meter warmed up. All this gear's been on for hours and hours and hours and hours. The plug-in's been burning in for a while. It was very stable, never had a problem. No excitement in the lab, which was good after a rebuild. So what I'm going to do is I'm going to start going through the calibration procedure. If we get stuck, we'll figure it out. where to go next, but that's the equipment that I expect we'll be using for this calibration. As with everything, we start with power rails. And if I had waited a few more minutes, we get this nice happy little message. But it wants to do the enhanced accuracy. And it'll run. Alright, I'm going to just let that run while I get busy on the rest of it. It's warm in the lab today. Towards the back of the instrument, there are these two resistors right here. Those feed right into the plus minus 16 volt test points. I found it easier to clip my leads there to get the measurement. So that's where the test probes are. I'll move you guys up to the meter and we will adjust the power supply. It's not bad. It's off a little bit. 30 millivolts. So no problem there. The adjustment pot is this gray one. This is the adjustment pot right here. It's down towards the bottom of the unit. So I'll move you guys up to the meter and then I'll do the adjustment. Okay, I have the meter set up with the reading and the graph. The graph will give us kind of an analog movement to the meter. I should have done that when I was doing the receiver. Would have made the AC measurement better. This wants 33 volts. Way too high. Way too low. Oh, this is going to be fiddly. It's not moving much. I think we're going to be good right about there. That looks good. Okay, I'm set up to test the 5.2 volt supply. Ground is picked up from this resistor down at the bottom. 5.2 volts is up here at the top. And I'm reading 5.15. I will move you guys over to the meter. 5.15. And I'm allowed 4.9 to 5.5. So that is fine. Now I need to do the R215 measurement or adjustment, which is the 100 volt regulator. That is for the main calibration. I need to shunt the meter with the 1 megohm because these meters have 10 megohm. So let me get that set up and I'll be right back. Okay, the regulator adjustment is right here. It's the multi-turn pot. That's what we're going to be working on. Test setup is, I have to be careful with this because there's 100 volts on the resistor. B and C to banana. The 1 megohm resistor is going into the banana plugs, and then the lines are going up to the 7510. So I will move you guys over to the 7510, and we will go from there. Okay, the 100 volt regulator is on, and of course it's off because we've had to do such a major rework of the plug-in. So that's going up. I need to go down. Ooh, that is a touchy control. I'm going to call it right there. That is adjusting millivolts on 100 volts. That is a very touchy adjustment. Okay, now I need to check the 50 and 20. I think I want to dial it up a little bit because my 50 volts is a little low. How about my 20? I need to stop this. I'm looking at the wrong meter. $19.98, that's fine. Yeah, that's a little bit light. No, that's good. I'm allowed 925. So that's okay, yeah. So 100 volts. Yeah, I think I'm going to dial it up just a touch. That looks a little better. $49.96. And I'm allowed 925, so that's fine. Let's go to 20. 1998. 1997, so that's within spec as well. So those two are good. Now we have to adjust the 10 volt regulator, which is R340. R340 is right here down at the bottom. And it looks like just breathing on the control just by pointing it out got it closer. All right, let's see what we have. Come on. There we go. Oh, so many digits. All right, that's about as good as I'm going to get. There's kind of a dip in the control. If I just bump it, it'll fall below 10. So I need to record this for the next step because it mentions that in part B. So let me write this down real fast. Okay, so let's check the 5 volt. Perfect. 2 volt. Yep. 1 volt. Yep. 0.5. Yes, we make it. 0.2. Yep, we're good. 0.1. Yeah, we make that just barely. Okay, so it's reading a touch high, but it is reading accurately. We're within specifications, so that's good. Good to go. I don't need to, I have an accurate enough meter. I actually don't need the current source, so I'm just going to keep dialing it back because this is a 7.5 digit meter, so this should be able to read it just fine. The accuracy's plenty good. So there's 50, 20, 10, 5, 2, 1 millivolt, 500 microvolts, 200 microvolts, and that's as low as we go. So, yeah, I'd say we're good. We are good there. I really don't use this calibrator in those ranges anyway, so if for my needs, that's plenty good. Okay, wants us to go back up to the 100 volt range. Now we're checking the offsets. Okay, there's the 100 volts, and I actually don't need to adjust these because this is behaving normally. I'll show you what it's supposed to do. On the front of the meter, this is the R450 adjustment. It should, the high and low light should be bouncing, and it should be a deflection error of 0.0, which it is. Let's check the 107.3 volts. And it should read 6.8%. low, and it does. Show you the meter. 107.3, which is perfect. Now let's check plus 7.3%. So I want 93.2. There's 93.2. And we're back at the calibration generator. So that is perfect. So now I'm just going to check the table here real quick. I just got to run through a bunch of set points, and then I'll be back. Okay, I did the 50 ohm testing. I wanted to do that real quick because it's just running through. There's no adjustments. It's just validating that it can drive 50 ohms and that the tolerances were correct. So it's a 50 ohm terminator as close to the output as possible. I used the precision 50 ohm cable that came with the SG503 to do it, but the best 50 ohm cable you have to go up to the voltmeter, I then used a BNC to banana to get it into the meter. So that's how you do the 50 ohm validation. We're into periods, so I have to turn this off and turn the square wave back on, which should be fine. Okay, the unit is off and powered down. The way you turn the square wave back on is you take this switch and you flip it down, which is how we can get highly accurate measurements out of the calibrated square wave, because we did it at DC, not on the waveform. Alright, this is one of the places where I'm going to deviate from the plan. It wants us to do this on a scope. I have a frequency counter with a GPS disciplined oscillator as the reference, so I'm just going to adjust 587 to the frequency counter and just call it a day. I did back it down on the amplitude so it won't blow the front end of the frequency counter, but we need to adjust our 587, which I believe is actually on the other side of the instrument on the daughter board. Right here. So let me adjust this for exactly 1 kilohertz. And I'll move you guys up with the frequency counter. Good enough for me. Okay, the next step was checking the high amplitude output unterminated, the max amplitude set into 50 ohms, R790. This was a little confusing. So they want you to pull the signal out, high amplitude, all the way clockwise, pull the signal out and send it up to a scope into a 50 ohm terminator. And you adjust R790 max amplitude set for 5.2 volts. We are a little off. R790 is right here that needs to be adjusted. We're going for 5.2. I'm doing this on the Rigel because it has good measurement. And there's our 5.2. Right, VP peak, 5.2. All right, I've got the scope changed for 10 volts per division, 1 megahertz. Let's pull this up. Give me faster speed. At the highest speed, I get at least 60 volts peak to peak, which is what we needed. I'm running about 64. You can definitely tell, turn off the measurement here, that at 1 megahertz we are stressing the oscillator because the waveform is not really a square wave anymore. Okay, this test setup's a little confusing as well. So you have both channels of the fast rise. The pulse amplitude needs to be all the way down, you're setting the pulse minimum, which is this potentiometer right here. Pulse minimum right here. But you want to measure both pulses at the same time, and you want one of them to hit 80 millivolts. I'll show you the scope. I have both cables coming in. One's on channel 3, one's on channel 1. Both are terminated into 50 ohms. Everything's on. I have measurements set up for all of the waveforms. And I was looking at peak to peak, 80 millivolts channel 3 hit first, which is for me the fast fall, not the fast rise, which is fine. The reason I'm using channel 1 and channel 3 is because I wanted the scope in the fastest configuration I could get. That has to do with the DACs internally to the Rigol. Each pair of channels shares a DAC, so we have, or an ADC. So we have one ADC and then two ADCs. To get the fastest sample rate, I use channel 1 and channel 3, not channel 1 and channel 2. So bump these channels up a bit. And now we crank up the amplitude. And we want to make sure we can get over a volt peak to peak, which we can, so everything is good. Next step is checking the aberrations on the fast rise inputs. So that's going to be C1000 and C940. So I'm going to flip over to the DSA for that one, because the Rigol is not going to be good enough. Nowhere near. So I'll find those two capacitors, and then I'll move over to the DSA. Okay, here we are coming into channel 1, checking the fast rise. That looks really good to me. I don't think I'm going to mess with that. I'm getting a rise time of sub 1 nanoseconds. And the waveform looks really good, so this is -1 volt to ground. My ground reference is here. So let's check the fast fall. This is going to confuse the scope greatly. Bring ground reference down. Trigger point needs to come up. Trigger also needs to happen. How do I set falling edge? Let me find that out here real quick. That's how you set it. Trigger, slope, negative slope. Measure. Measure. Measurements. There we go. We want fall time. Fall time. and exit. And we have a fall time that is also very well defined. I don't think that one needs to be messed with at all. Nice waveform on the fall. And there's very little ringing or anything like that, so it's validated up to a gigahertz now. We can stretch this out a bit. Let it build the sample. So, for the equipment that's in my lab, that's as fast as I can go at the moment. But it looks good. If you do need to adjust, the output capacitors, they're actually on the bottom. And as usual with my videos, the dish of shame. These are the caps that I replaced while doing the rebuild. These two big power caps, these are in the switching supply. These were fine, but I was in there and I was going to redo the cal anyway. These guys, however, were not so fine. Here's just a random one I picked up out of the bin. Not even a capacitor anymore. Not even a capacitor anymore. This one's okay-ish. A little bit high ESR at 1.68 ohm. These are also very small. This is only a 2 microfarad capacitor, so these are tiny. Eh, 1.92, still getting high, almost 2. 2 ohms ESR. Doesn't even know what this is. Tells me it's got a low ESR. This is a 50 microfarad, 50 volts. Says it's low ESR, but doesn't even know what the capacitance is. Now it doesn't even know what it is. So that one's toast. Still high ESR. There was one in here when I tested it. It's probably one of the ones that's open circuit. There was one in here that tested like 40 ohms ESR. Like it was huge. Yeah, so 0.5. So it was time. Half of them aren't even capacitors anymore. The other half are marginal at best. So good time to get them out of there. Thanks for stopping by the lab today, taking a look at the restoration and calibration of this PG506. I'm getting a lot of questions about the scope cals and things like that when it comes to what can we use besides, is there other equipment that can be used, because a lot of people want to try calibrating their own scope. I do have a video in the works that's going to go through what makes the SG503, 504, the TG501, and the PG506 special, so you can evaluate what you have on hand to see if it fits the bill, and you guys and people will be able to try a scope cal themselves. Also, let me know how we're doing. You guys are the whole reason we're here, and we definitely appreciate everybody being here. I will see you guys in the comments and in the next video. Bye for now.